Good day, class. Welcome to another edition of Class University Secondary School online chemistry class. I am Solomon, your online chemistry teacher. And in our last lecture, we discussed the remaining chemical property of hydrogen chloride when dissolved in water to form hydrochloric acid. And after that, we talked about how you can test for hydrogen chloride in the lab and some important uses of hydrogen chloride and also for hydrochloric acid. And this is the assignment of the last lecture, and here are the solutions to the assignments. And in our lecture today, we're going to discuss another important derivative of chlorine, which is chloride. Now, under chloride, we're going to just do some introduction. Then after that, we'll talk about their laboratory preparation. Then we'll talk about their properties. After that, we'll talk about how chlorides can be tested for in the laboratory and some important uses of chloride. Now, chloride are normal salts formed when metallic ion replace the hydrogen ion present in hydrochloric acid. Now, this is an example of a metallic ion, and this is hydrochloric acid. This hydrochloric acid can also be the hydrogen chloride gas. Please let's take note of that. That's why you can see that I didn't indicate any state of matter of both the metal and the HCl, because it can be HCl as an acid, which is hydrochloric acid, and also as a gas, which is hydrogen chloride gas. Now this hydrogen ion here, it has been replaced by the metal, this M, this metal represented by M, which form MCl and liberating hydrogen gas. Now please let's take note that all chlorides are soluble in water except the chloride of copper 1 chloride, mercury 1 chloride, silver chloride, lead 2 chloride, which is PbCl2. Now copper 1 chloride is CuCl, which is different from copper 2 chloride, which is CuCl2. Mercury 1 chloride is Hg2Cl2, which is different from mercury 2 chloride, which is HgCl2. Now, lead 2 chloride is insoluble in cold water, but tends to be soluble when the solution is heated or when it is warmed. Now, let's go to the laboratory preparation. Now, when you are preparing chloride, we consider two things before we prepare any chloride of any metal. Now, the first thing we consider is the activity of the metal. That means how electropositive the metal is than hydrogen. Now, from here we said chlorides are formed when metallic ion replace the hydrogen ion present in HCl, or that means hydrochloric acid or hydrogen chloride gas. Now, so we consider how electropositive the metal is. Then after that, we consider the nature of the chloride, whether the chloride is soluble in water or is not soluble in water. And the first method we are going to be discussing here is action of hydrochloric acid or hydrogen chloride gas on metal. Now, this method is suitable for preparing any soluble chloride. Let's take note of that. It's suitable for preparing any soluble chloride. Now, this is magnesium reacting with hydrochloric acid to form magnesium chloride and liberating hydrogen gas. Same also for iron. Iron reacting with hydrochloric acid forming iron 2 chloride plus hydrogen gas. Now, the second method we are discussing is action of hydrochloric acid on oxide, hydroxide, or carbonate 4 of metals. And this method is used to prepare chlorides that are more electropositive than hydrogen. Chlorides of metal that are more electropositive than hydrogen, like the sodium chloride, the potassium chloride, and calcium chloride. Now, this method is also suitable for preparing copper 2 chloride. It's suitable for preparing copper 2 chloride. As you can see, the reaction is just this reaction is just a neutralization reaction. As you can see, this is sodium hydroxide reacting with hydrochloric acid forming sodium chloride plus water. This is copper 2 oxide reacting with hydrochloric acid forming copper 2 chloride plus water molecules. And this is potassium carbonate 4 reacting with the hydrochloric acid to liberate CO2 gas and form potassium chloride and some water molecule. So you can see that it's just a basic the basic neutralization process. And so the next method, which is double decomposition. Now this double decomposition method is used to prepare chloride that are insoluble in water and chloride of metal that are less electropositive than hydrogen. Now, metals that are less electropositive than hydrogen, we have mercury, we have silver, and we also have gold. Now, as you can see, this silver nitrate, HgNO3, reacting with sodium chloride, forming the silver chloride and the sodium triosonitrate 5. Now, please let's take note that sodium is more electropositive than hydrogen, than silver in this equation, while the triosonitrate 5 ion is more electronegative than the chloride ion. Now, the more electropositive metal we want to combine with the more electronegative anion or more electronegative ion. That means sodium will always want to combine or to form a compound with triosonitrate 5 in this reaction. That's why you have NaNO3 being formed. Now, the less electropositive metal, which is silver, will now go for the less electronegative ion, which is the chloride ion, to form the silver chloride. Now, please take note that mercury 2 chloride can never be prepared using this method. Now, to the last method we are going to discuss is the direct combination. Now, this method is suitable for preparing any type of chloride, any type. Now, for example, under the appropriate condition, chlorine gas can react with heated mercury metal to form the mercury 2 chloride, as we have in this equation. This is the mercury metal. As you know that mercury is the only liquid metal we have out of all the metals in the periodic table. That's why it's represented by L, which is showing its physical state in liquid form, and the chlorine gas forming the mercury 2 chloride. Now, to the properties of chloride. Now, all chloride do not decompose by heat. Now, no matter the temperature you apply, no matter the temperature of the heat that is applied to them, they do not decompose by heat. Now, when they react with tetrasulfate 6 acid in the lab with hot concentrated tetrasulfate 6 acid, they produce hydrogen chloride. Now, if we check our lecture on the preparation of hydrogen chloride, you see that this is also the reaction we are just talking about. Now, also, when a metallic chloride is heated with strong tetrasulfate 6 acid and a strong oxidizing agent, chlorine gas is liberated. Please let's take note of that. Now, this method is also employed in the lab for the preparation of chlorine. Now, for example, we talked about the preparation of chlorine from potassium manganate 7, tetraoxo manganate 7, acting or being reacted with concentrated tetrasulfate 6 acid. Now, the potassium tetraoxo manganate 7 can be prepared by the action of potassium chloride reacting with manganese 4 oxide, which is MnO2, and tetrasulfate 6 acid. When we combine the three together, we'll have the chlorine gas to be formed. Now, to the test for chloride. Now, most chloride in solution of silver triosonitrate 5, which is HgNO3, acidified with triosonitrate 5 acid, gives a white precipitate of silver chloride when added to silver nitrate. And that means when you have a solution containing a chloride, then we add it to a solution containing silver triosonitrate 5 that has been acidified with triosonitrate 5 acid, a white precipitate of silver chloride is always formed. And for example, we have potassium chloride here reacting with the acidified HgNO3, forming the potassium triosonitrate 5 and a white precipitate of silver chloride. Now, please take note that the silver chloride forms a precipitate because it is an insoluble chloride. Now, please take note that the white precipitate is soluble on addition of excess aqueous ammonia. Now, excess aqueous ammonia is also the same thing as ammonium hydroxide. And this is the equation showing the second part of the state of the reaction. This is the silver nitrate reacting with excess aqueous ammonia and forming a complex compound and some water molecule. Now, please take note that when we talk about test for chloride, we test for the chloride ion present in the chloride. I want you guys to take note of that. We talk about the chloride ion present in the metallic chloride. And to the uses of chloride. Now, sodium chloride is used in food and preserving fish, meat, and other materials. Ammonium chloride is used as an electrolyte in dry cells, and sodium chloride is used for the industrial preparation of chlorine and hydrogen gas. Now to the uses of chloride. Now we have so many uses of chloride, but we are just going to mention three in this our lecture. And the first one, sodium chloride is used in food preservation. As we all know, when we add our sodium chloride, normal table salt at home to our food, we use it to give taste to the food, and we also use it to preserve food like fish and meat. Also, ammonium chloride is used as an electrolyte in dry cells. And also, we know that sodium chloride is used for the industrial preparation of chlorine and hydrogen gas. When we talk about the industrial preparation of hydrogen chloride gas using the electrolysis of brine, now you know that the brine is a concentrated solution of sodium chloride. Now today we've come to the end of the class today, and I have some assignments for you guys also, and I want you guys to submit the assignment to the given email given to you guys to submit your assignment. Thanks for watching this edition of Scholastic Secondary School online chemistry class. Hope to meet you again in the next edition of the class. Thank you.